There we have medium problem. Given the grid, we traveling from the top left to bottom right. We can move to the right and to the down. Now each cell has some number, 1, 0 or 2, and that means that there are rules to cost 0, 0, 1, 1, 2, 1, and value that we obtaining, so it's just 0, 1 or 2. Now they ask us to find what are the maximum value we can collect by traveling, and we shouldn't exceed the cost, k for cost, or maximum allowed. Now the solution is dynamic programming. We have to consider, so imagine we add that cell, we have some previous history of our current cost and current position xy, and we have to decide which way we should go, to the right and to the bottom. If we go to the right, we have some result. If we go to the bottom, we have other result, and then we have to pick the maximum value we are collecting from that cell. And the main hardness or mediumness of this problem is that you have to consider if your current cost is bigger than k, then you should dispatch it back to this result and didn't consider it. So I use some marker value, just very big negative value, and it naturally would left, right and bottom, it would naturally give me correct result. Now let's look at the code. This is a simple DFS DP with a cache over hash map. I use a k, and this is some corner conditions, like don't exceed the grid, don't exceed the new cost of the k value, return the final position if you are at the end cell and pick the maximum. And in the final step you have to check if your most positive value is actually positive, or it only contains the disallowed values. So now let's look at the Golfet solution. It's kind of very similar. Let's start with Kotlin. By the way, I spent 10 minutes to write this first variant and almost 1 hour the Golfet. Now this is Golfet version, and it's just rewritten into more interesting way. Less ifs, less returns, just get on null. This is some hacky variant. It would return NC bigger than k by giving it 4000. And the final step, check the last cell and return the max. Now let's look at the Rust, and the Rust is iterative version, and the iterative version has a little bit more interesting way of describing the logic. So if you go in the iterative version, you don't check in the next cell that you would go. Instead, so iterative, instead you are at the current cell and you check in the histories to the left and to the top, and you don't just check in these histories, you also have to store individual histories with costs. So for each previous cell you have entire like array of possible costs, and this the same for the left cell costs. And then at the current cell you're taking your cost in 0 up to some value, like up to, let's look what's that value, k plus 1 minus cost. So k minus cost is the current cost of the current cell, and you iterate in this. By adding some like c++ for the cost, and you doing this is called dp. dpx is your top previous, and dpx minus 1 is your left previous, and each of the dp has costs, dimension costs, and you have to check for each of this range for the current cell and propagate and like pick the value from left and right, or left and top, and then you say that cost c plus cost. Okay, your cost, you're taking your cost and incrementing by c. So your cost is just your value, let's describe it. Then you take in this all the costs, and you making this array, one-dimensional array of all possible costs by looking at the top and on to the left of this same cost, and you saying that top and best of top and left plus your current cost is a new value, and the p is the previous. So you're taking this maximum, and this is a previous for the c value, and you making it to the next c plus cost. So this is how it looks like. At the final step you have this one-dimensional costs, and you take in the maximum. That's it for today.